Welcome to AMR One project video series. In this video, we will explore how to implement cloud monitoring using Amazon Web Services. What will be the content of this video? First, we will talk about the objectives. What we want to do is just connecting an AMR, autonomous mobile robot, to the cloud and showing some data there. We will explore the architecture, how we will implement that, the activities that will be involved on that, how to do ROS publishing, because the AMR works with ROS, how to do MQTT publishing, because we will use the AMR as an IoT device, and in the Amazon Web Services Cloud, how to implement the IoT core, the Open Search, that is the new name given to Elasticsearch as the open source version from Amazon, and using Open Search dashboards, that is the former name Kibana, from Amazon. Okay. So let me show you about all that, how am I doing that kind of things, and very quickly. This is the project management of the project. I will not go in deep in that. For that we have other videos, but basically it's just a reminder that this is an AMR, is development of personal project, the development of an autonomous mobile robot prototype that might be useful for the real world. And this is the AMR from one side, and from other is a kind of AMR that has laser scanner, safety, and different functionalities. What I'm trying to do with that, as mentioned in other cases, there is a roadmap. Okay, there is a product roadmap, a kind of product roadmap. So even being a personal project, it is managed like a real project. So there are different functionalities or features, and how they are implemented in the time. Okay, and we will focus on this last one, the basic data monitoring for the cloud. Okay. What we have to do is to understand that this product has requirements, okay, and for that I have defined the different requirements, and in the case of basic data monitoring there are some specific requirements. Very simple, okay, it's just monitoring some specific data, like information coming from the AMR, specifically about the safety and some things. It's not very strict and very detailed. It's just a proof of concept. Okay, so how are we going to do that? Well, I work on the design of the general architecture, and how are we going to implement that. This is basically the AMR, and this is how I'm going to implement that in Amazon Web Services. Okay, just reminder on what we have in the part of the AMR is that we have different devices that we might show in another moment. But basically all these devices that we have are connected to what we call the low-level controller. There is a high-level controller and a low-level controller. Low-level controller is based on an Arduino, and high-level controller is based on a Raspberry Pi. Okay, and the low-level controller is connected to everything. It means it is connected to the motors, to the drivers, and all the different parts from the AMR. Okay, this is the low-level controller. It's just box connected to everything, motors and encoders, laser scanners, and all that kind of things. Okay, and how am I going to implement all that? Okay, let me first show you something that might be interesting about this is a document that I have for everything. Just I wanted to share with you what I am talking about. This is the high-level controller and the low-level controller, how they are connected. So this is the low-level controller and the high-level controller, and they are connected, the low-level controller, to different devices, drivers, motors, also to a safety scanner. There is a safety PLC sending information to here. It's not so relevant, but it's just as a summary that everything is going here. Safety stop buttons and different conditions measured, a magnetic band sensor, RFID tag in RFID interrogator, different things, and there is a high-level controller that has more functionalities based on ROS. Okay, and there is topic transfers from one side to another. Just as a summary, so you have a general idea on what is happening, so you understand later all the topics and everything. Okay, so basically, how is this working? Is that the LLC, the low-level controller, is sending some some information via ROS topics. Okay, there is a ROS implementation here. I will explain a bit later. And this information is going to the high-level controller, where there is an interface that is really as a parser to send the information through an MQTT client to the cloud. Okay, and in the cloud there is this IoT core service that is taking all these messages, and using a core and Amazon Web Services IoT core rule, there is this rule sending information to Amazon Open Search service that is a NoSQL database kind of thing. And from here we could take the data from Open Search service dashboards, that is Kibana really, and we could in near real time show all these things to the user. Okay, basically, just as a summary, what we are going to send is this information. Okay, so what we have here is that in the previous image that I will put here somehow, there is some transfer of data. Okay, and basically it's a timestamp because we are going to use it as a log. Serial number for the AMR, because we consider we could use several AMRs. The linear velocity, angular velocity, the safety status. So this low-level controller is sending in just one message all this data, and then it will be parsed here to an MQTT with different messages. Okay, so back button status is a button that is at the back of the AMR. The last RFID tag read by the AMR, and any error messages. And how this information goes, so release through a JSON message. Okay, so is how I explained before, that it goes through MQTT. MQTT message is based on JSON. Okay, so the parser is just creating the JSON with all the information I mentioned and sending that to the IoT. Okay, so here is the origin of the information that we are going to send. As mentioned before, there is some information coming from high-level controller and low-level controller. So here we have three different things coming from the high-level controller and different other topics coming from the low-level controller. This is just in the moment that we are architecting the solution, we are understanding where things are created, or where the variables are created. So we could then do a correct planning of the solution. Okay, so next thing I'm going to show you, as I explain how are we going to do, or what are we going to do, is how things are planned. Okay, for that I use Big Picture, that is an application over Jira. I use Jira software for that, and basically this is quite simple. Okay, this basic data monitoring is something that really doesn't have so many tasks. So it's something that I just created the different tasks and organized how I'm going to do all them, and divided in the different sprints, that because we will use agile methodology. If in other cases it was more complex to do or to find the solution, in that cases you have to use work breakdown structure, but it's something I use in different part of the project, but not in this case, because I think that there are very few tasks to do that. Okay, so let's go on how this is executed. One of the things is to start implementing this transfer of data from the as explained in the architecture, from the low-level controller to this high-level controller. As I mentioned, there is ROS. This one has a Linux and ROS version 1 here. And for the low-level controller, what are we going to use? ROS serial. ROS serial, you could find everything here in ROS organization. ROS serial is something very commonly used to connect devices to a ROS core, let's say. Okay, everything is explained here and is quite easy. So how am I doing that kind of things? Really, I am taking that information from here. There are examples, you could check that, no problem with that. And then you just go to the Arduino device, and in that case I have the application for Arduino here is doing a lot of things, but really where I want to show you is that in the code there are parts that are specifically for this sorry, for this here it is, for this integration with ROS. Everything is explained in the page I mentioned. That is just creating here the publisher. Okay, so we will publish the velocity, the linear velocity, the angular velocity, the safety status, RFID tag, and some other things. And after doing that, there are some initial, let me go very fast here. Here is it. In the setup, there are different parts related to ROS. Here, not really. Let me see. Okay, here the ROS integration. Okay, so some additional things for advertising these topics, and here there is this other part. Okay, with ROS integration in the loop. Okay, in the main loop, where it's just sending the information. Okay, just publishing that. Doing this publishing of the different velocities and different things. Okay, so it's just publishing. Everything is perfectly explained in the documentation. Is quite straightforward. Okay, so I explained here how I am doing this part. Let's go to this other part, and this other part is where we will send things. Okay, here there is a program that connects here. So how am I doing that kind of thing? Really, I'm going to use Amazon Web Services because I think it's a quite good thing for this, and Amazon is investing a lot in robotic solutions, the cloud, and there is these Amazon Web Services, robotic solutions, and all that kind of things. So this why I'm using this one. Okay, so the first thing is to create here. This is a service offered by Amazon, and we need to create a service to connect to this device. Okay, so how are we going to do that? First thing, you need to have a user in Amazon. Okay, so in Amazon Web Services, there are many videos around there how to do that. Okay, then whenever you have that and you selected the somewhere you are going to work on, okay, then you just look for the IoT core service. Okay, so you just go here. Okay, IoT core, and when you are here, you just create what is called a thing or a device. To connect the device, you have a lot of information here on how to connect. The first thing is that you have to register a device. So each AMR would be a different device. You have to register each of the AMRs that are here, and then you have to download a connection kit, that is some software and some credentials and things like that. Okay, so you have to download all that kind of things, and then you have to configure and test your device. I will not go much in deep, just to mention that here I choose this platform because is the platform to which I'm going to connect. As mentioned before, this is where I am going to connect, and this is the Raspberry Pi with a Linux version. Okay, a Linux distribution. So what I have to choose is that I'm going to use this one. Okay, and what language I'm going to use here? Well, as mentioned, I'm going to use Python. Okay, so I will use Python for this connection. So just say Python or whatever you're going to use and go next. And the next thing is to create your thing. Okay, you could continue here going ahead with that. You create your thing like AMR 001 or whatever you create or whatever your device is, and you continue following several steps. I will not follow these steps because there are a lot of documentation about that, and I don't want to be another one talking about the same thing. Okay, but basically the next steps are that you download this connection kit for Linux. You have to download that in your Raspberry Pi. You create this thing, you create certificates and policies and link them and all that kind of things. But there is a video really that I could recommend a lot. Is this one, connecting Raspberry Pi to Amazon Web Services IoT Core, is exactly what we are doing using Python and Amazon Web Services IoT. This video is great. You have the link here. Okay, so you would see here the link, and just take this one and look for that, or just search for that. This guy Rishabh is great. So just to mention that you have to go to his page. This is a 13 years old guy, and this guy is amazing. A lot of videos about Amazon and about programming, and this guy really is great. Explains things very easy and is smart and knows really a lot. So I really learned a lot from this guy. Okay, even being 13 years old, that's not the important thing. Okay, so you have to prepare everything and get that. Okay, what at the end you have you at the end you have a created services. Okay, a created service. So you could go through all that things. For example, I create a thing that is this AMR 001. You see this one with different details and all that kind of things. Okay, and at the end, what you have is this this service created. Okay, so um, what at the end do need is to have that thing created and prepare a kind of rule. Okay, so here we create that thing, and the important thing is this rule. Okay, this one will receive the data whenever you have created that one. You could start testing that. Okay, so how are we going to do that? Well, really, you have to use a program that I will mention a bit later, but basically send this information that I mentioned before here with these JSON messages. Okay, and it will send that information here. How you test that? Okay, I will show you. You could go to the service, and here in act you have rules. Sorry, test. We will see rules later. Okay, test, and here you put here the topic you are publishing. Okay, in MQTT. In my case, this one is AMR 0. AMR One. Sorry, I have everything. AMR One, 001 data. Okay, so I will subscribe, but I'm not publishing anything at this moment. So I have a, I will activate it. This is happening in the in the in the AMR. Okay, so you have it's running at this moment and starting all the connection, and now it is publishing. Okay, so at the same time it is publishing here, it is received here. Okay, it's a way to test that. Everything is described in that video from this guy. Okay, so I go ahead. So far we have this part done. We have this, we are receiving the messages, and I will explain you a bit more on that, because you said, okay, you have everything, but you didn't talk about that. Okay, yeah. I know. So how I did that? Really, what I did was programming Python. Is this one? Okay, that is in the high level controller, the AMR, and there is something here. For example, this one is how you connect. Everything is described in that video. Okay, is how do you take the libraries from Amazon Web Services. Okay, there are some initialization part that is really connecting using the certificates. Okay, and then there is this other part where you publish. Okay, in the main loop, I take just the payload and publish that. Okay, so I publish that on MQTT, and you see this is the list of the different topics I mentioned before. Okay, so these topics I mentioned, all these topics here, you see, are the same. Okay, so this is very easy. You see, when you understand that, this is the topic. You see, AMR 1001 data, and is why we are receiving here. Let me show you AMR 001 data, all this data. Okay, that is in the same format as we seen before. Sorry. Okay, so it's the same. You see, the same format. Okay, having said that, one of the things I wanted to mention also is that there is a parsing. What parsing? Well, here I mentioned that some things are coming from the low-level controller and some from the high-level controller. And I mentioned that there is a communication, a ROS communication, ROS topics, messages-based communication from low-level controller to high-level controller, and I need to parse from these ROS topics to JSON messages to send it in MQTT. Okay, so coming back to that, what I do in the program is very simple. Is that I have, if you know ROS, if not, you need to understand ROS, obviously. But basically, what I have is that. Let me come here. Okay, this is the main part here. Okay, so we have the subscribers for the topics. You see here only 4 topics. Here are more, but as I mentioned, this safety status contains all these safety data and up to here. Okay, how really is a thing of different bits. The first bit is the first 2 bits are the LiDAR case. This LiDAR case is just the LiDAR. You could say to the LiDAR to work in different ways or to have different warning or protective fields. Here is if the LiDAR detected something in the warning field, it is an area surrounding the AMR. LiDAR detected something in the protected area, that is something the smaller area, that if something is in this area detected, then the AMR should stop immediately. If the LiDAR is dirty and if you push the safety stop back button, things like that. So really the parsing is down here. If a message is received from the low-level controller, so it's a ROS topic coming through this ROS serial that I mentioned before, okay, if this is happening, then it goes to this callback function. Okay, there are different callback functions, and the callback functions, sorry, are these. The only thing they do is to take the data coming from the ROS topic and store that in a variable. And here, this one, the safety status, is where this parsing is done bit by bit. So it storing the different variables, the different conditions. And that's all. Then in this loop, is just taking all that variables and publishing that in MQTT. Is only that. Is extremely simple. Okay, nothing more than that. So what is the next step? Okay, the next step is that now we have this parsing. This really, the MQTT client is what are the libraries that you download from Amazon and that you call from your program. Okay, these libraries that are called here. Okay, and these functions to publish everything. Okay, so here I really create this payload is a JSON object. You see, it's a JSON object really. So I create this JSON object here, so the parsing is done here, and then I use the libraries to send. And these libraries are those that are here, MQTT client. Okay. This one is acting as a MQTT server and organizing everything. Okay. Next thing. Well, if you want to create a rule to send something here, then you need to create this before, and then you create the rule, because otherwise you create the rule and goes nowhere. So let's focus now on this Amazon OpenSearch service. Well, Amazon OpenSearch service is, let me use this thing because it's quite, this image is really great. Amazon OpenSearch is really what used to called Elasticsearch. Okay, it's just that Amazon took Elasticsearch open source part and offer as a service. Okay, but in general there is a lot of documentation about that, and I will share with you some later. But basically, what you have to do in Amazon OpenSearch or Elasticsearch service or OpenSearch, how is how they call that now, is that you create a domain. Okay, you create a domain, and in that domain you could create different indexes. To compare with the traditional SQL databases, each of these index would be like a database. Okay, so don't be confused by this word index, because in former databases, index was like the key where you index a database, but it's not here. These index are like each one would be a database, and there you would have types, and each type would be like a table, okay, in that database. And then you have rows that are the records, and you store in JSON format. It's a non-SQL database. Okay, and also you have something that is mentioned here. How do you explore this data? Using OpenSearch Service Dashboard. OpenSearch Service Dashboard is that formerly was known as Kibana, but this is the same. So you have the data here. You would have this Amazon Elasticsearch or OpenSearch, and then you could use Logdash if you want. I do not. This is you could do parsings here and filtering and many things. And from the sources, sorry, and you have this data in Elasticsearch or an OpenSearch, as I mentioned, and then explore that from Kibana or from OpenSearch dashboard. That is at the end the same, and then you see. Okay. In general, I recommend you this video, an absolute beginner's tutorial for Amazon Elasticsearch. It's a great video. You have the link here. Okay, is this one, the short one, and if you see this video that is from AWS tutorials, it's a great video, really, to understand the basics on Amazon Web Services, Elasticsearch or OpenSearch, how they call that now, is great. I recommend that really a lot. Okay, and it's very clear how it is explained, everything. Okay, so what are we going to do now? I explained you more or less that thing. So we need to create, as I mentioned before, this a domain first thing, and then an index, because we are going to use just one database, and in fact one table, because this is just a test. Okay, and then several records. So we will create that. The first thing is to go here, and you do as before. So you go, this is Amazon Web Services, the console. When you have a user, you go directly to the console when you log in, and here you go to OpenSearch service. Okay, so you have here the service. Okay, and you could here create a domain. Okay, so this is really very simple. You could create a domain, and here you put the domain name, as I mentioned before. You remember that thing, the domain name. Okay, in my case I created something like monitoring, AMR monitoring or something like that, and well, you have to detail different things. It's very simple, extremely simple to create that. Amazon did a great job to make it simple. I recommend you, I will not go in all the details because there are many videos, but I will recommend you this one. This one that is from Mahesh Kariya. He explained all that, okay? OpenSearch service, Kibana dashboards, and set up Elasticsearch, and all that kind of on Amazon Web Services. Okay, so this is the link that you have to connect to that video, and everything is created on that one. Okay, so what I have at the end, at the end you get a domain. This is the domain I created. Okay, and when you go to the domain, you have different things. Okay, in terms of security, in terms of cluster health, many things. I will not go in deep on that because you have the former video. But something that is interesting is that you get this OpenSearch dashboard URL. Okay, so you have to click on that one. Okay, and then clicking on that one, you go to, you see, you go to this OpenSearch dashboards, that is the former Kibana. The only thing that you have to do here is to create an index. It's an easy way. You could create that in many ways, but here you created the domain, that is the one I mentioned before, is this one, AMR monitoring domain. This is the domain. Okay, and the next thing you have to do is to create this index. So there is a very easy way to do that, and is go here and move down to DevTools, and here you could put different commands. The one that you have to put is put AMR. Why AMR? Because I want to create an index called AMR. Just that, give any name you want. whatever you want that is suitable for your application, and that's all. So when you do that one, you create, this one creates, so what is that? Why it doesn't work? Oh, okay. It doesn't work because I already have that one. Okay, if I have this get, okay, I have many things here. Okay, so if you just create that with put, you will have here a message like okay, and that's all so far. Okay, so you get that that index, that would be AMR. Okay, having done that, we could go back to this architecture and see that we have this thing created, we have this thing created, we have access to this one because it's this thing. You could do many things. Okay, this is the DevTool thing, that you have dashboard, you have many things. We will see that. So we have so far all that. We have created that, we have created that. We need to create the dashboards, but we will show later. And now we need to create the rule. Okay, so let's focus on the rule. For that, let's go again to the console and say IoT core. Okay, the rules, you find the rules in the IoT core. So you go to IoT core and previously we went to this test. You remember, in this test we had this part of subscription where you could say like AMR One 001 data, that is the topic, and you subscribe and you're receiving things. Okay, I'm sending because I have deactivated the AMR, sending this data. You see, this is changing this one. That is the timestamp. So it is receiving this data. But where I want to go is here, act rules. Okay, so in rules is where you create the rules. I already have rules, but I will show how to do that. It's also simple. You just put the name that is relevant for you for this rule, and you have to select what are you going to send. The only thing, the simplest way is just to put here, replace this IoT topic by your topic, the name of your topic. In my case, it was AMR 001, you remember? So it was in the test AMR 001, so it will just to take this thing and to put that in the rule, okay, in the select here. So it would be take everything from that topic. It would be that. You could filter, you could do a lot of things. There is a lot of documentation here. And then, okay, so you say, hey, I want to take all that things, all the topics that are coming in QTT, and what am I going to do? You could do two things. One is to set an action, and the other one is to set an error action. So if you set an action, this action is to move that information directly somewhere. So Amazon really made this crazy simple. So you just take, like, send a message to Amazon OpenSearch, or you could send wherever. You could, I don't know, re-forward the message again back, or do something, or send that to a DynamoDB table that is also a non-SQL database, or many other different services from Amazon. Okay, but this is the one we would use. Okay, and we would go here and we would choose the resource, because as we already have a database, we would choose that one. if we do not have that one, we would create that one. But as I mentioned here, we already have that one. So it's the name of this one. The name of what? The name of the domain. Sorry, of the domain. Okay, so it's the name of the domain. So you would check that one, and then the only thing is that you have to put here an ID, index, and type. Okay, but what is this? ID is what are you going to it would be your ID in the unique ID that you will use in your database. Okay. For that kind of things is very common to use a kind of reference that you use for this thing I mentioned. For example, here the index is what I mentioned, is the index of the database. So here is this one. So we created AMR, you remember AMR. So here it would be AMR, and the type is here. Sorry, the type is the table. What was the table? The type. We do not have the type. We will create that one. Okay. The good thing of non-SQL databases that if you do not have that object created, it will just create that one. So put here something. It's quite common to put underscore dot. Here we would put something like AMR, and then for the part of the let me focus. Okay, for the, because I am searching at the same time in other in the other screen. Sorry for that. But basically, what we will create here is, let me just check. I don't remember by heart. Here you put any role. You could just create one and it do everything and add the action. It would be finished. But this ID is I don't remember by heart. That here is this one. Is this one? Okay. This is the ID. So that one is the one we would use. This ID, this index that you created, the type, whatever, and it will create the AMR role. This is the summary of the one I have. I have to create this other one, this other action, error action. So whenever this data is these topics are received, they will go directly to this database. And if something happens, I could send that errors also to Amazon OpenSearch Service, for example, or to any other database where I would store the errors in the reception, not the reception of the MQTT, but the rule execution. Okay, so only here what you detect these errors are for the rule. If something happened in the reception of the MQTT message, they are not reflected here. Only the errors in the IoT role. Okay, having said that, if we come back to our architecture, now we have this rule created, so we have everything until here. The last thing that is pending there is to work on this dashboard. Okay, so as I mentioned, this is really Kibana. Okay, and you have a lot of videos about Kibana, but Kibana basically is a free open user interface that lets you visualize your Elasticsearch or OpenSearch data. and navigate the Elastic Stack. Okay, you can do a lot of things. So let's go there. And here we have this Open Search dashboard. From where it comes? Okay, it comes from, you remember this Open Search service you created, and we had this link. So just copy that one and you click that, and you get that, and you get here. Just store this address and use it, that one. You are asked for a user and password. Okay, the user and password that you created when you created Open Search. Open Search, the Open Search domain. Okay, so you get here, and what you could do here. Okay, you could do a lot of things. There are many videos. You just put Open Search dashboard or Kibana. Just put Kibana. There are many videos. Basically, what you have to create are visualizations using this menu, visualize, and dashboards. A dashboard is a set of visualizations. So you go to visualize and forget this one. Okay, you come here and you could create visualizations. These are visualizations that I already created. You click here in visualizations and you could say, okay, I want to create, I don't know, whatever, a line, and then you select here your index, okay, AMR, and you could do many things here. Just check the documentation. You could say like, hey, I want to see the average linear velocity in time, a date histogram. Okay, and okay, you have the graph and you see something here for the last 5 minutes. Interesting. But you could say much more, like, hey, I want 1 hour before, or I want to show dates. I want to, from absolute date, whatever, this date at this hour, till now, or till this other date, this hour, or till, I don't know, 2 seconds ago, or I don't know, relative 1 day ago, and here till now, and you say, okay, a day ago until now, and you update, and this is updated. You could do this kind of thing, so you select a range and fill that. Okay, so this is very simple. You could do a lot of things, and I created different visualizations, like for example, I have this velocity graph, and you see, okay, there are no results because this is showing me, I want to show, for example, 2 hours ago, okay, and here now, okay, and update, and now I have like weird data. I don't know, because I tested a lot of things. So here is the real data. Okay, so I could go to that things, and you could just save that with the data or not, or you could here say, hey, start refreshing every 10 seconds or whatever, because you want to refresh that. Okay, so you have these visualizations, and then if you have created several visualizations with different aspects, like you see this one I have, but you have many different, then you go to dashboards, and in dashboards you could create a dashboard, and you could create with new visualizations or use existing visualizations. Like, for example, okay, I want to include my I don't know, let me show you more. Velocity graph, it is added, okay, you see here, added. And you could add more, like, okay, my protected field ratio is added, and my, I don't know, LiDAR dirty graph is added. And you close here, and you have all these things here. You could reduce them, you could move them, you could modify from here them, like edit visualization, and you come back to the visualization, you change whatever, and you say save and return, okay? But I don't want to save and return anything. But you could move that thing, okay? It's very simple, very easy, and so on. The good thing of that is that if you change something here, for example, this one, this affects everything. All the graphs are updated, okay? All the graphs are updated, okay? Okay, after having shown you all this, I want to show the last part of this video is my dashboard. My dashboard has all these different visualizations in just one page. Okay, so just to explain you, this is, let me change this one, for example, put something like, instead of 10 hours ago, just, I don't know, 1 hour maybe, till now, update, or even less. I could say, hey, instead of doing just that, say that thing from here to here. But if I do that, I fix the time and I do not see the updates, okay? So I want to change that one, say from now, update, okay? Why I do that? Because I have here that every 10 seconds it updates. So every 10 seconds you will see like something else here, okay? So this is the AMR sending information, the angular velocity, the linear velocity. You could see the data when you go there, the protected field, warning field conditions aligned with the timestamp you see here, and here a table that I created with some information of this AMR One. There is another AMR that is with another name but it's not connected at this moment, but if there are more, you could create here a list of them and see what is the last status received. Here some radio, like, hey, how much time from, I don't know, imagine your AMR is working in a real situation and is moving from here to there, and you check in the last hour or 5 hours, what is the safety stop ratio? It means that for some reason the AMR is stopping, and this may affect the performance of your project, okay? Or how many warning field detections are. Maybe you have to change your warning field or something like that, okay? And then you have like 17% or more of warning fields are detected. In my case, when a warning field, an object is detected in the warning field, what the AMR does is to reduce the speed by 20%, okay? So every time a warning field is detected, only a warning field, the speed is reduced by 20%. It's the same here. And if a protected field is something is detected in the protected field, it also it is detected in the warning field, and it is activated the safety stop. Okay, the safety stop is that really stops the AMR. So whenever this is detected, it goes to zero. The speed goes to zero until the condition is recovered. Okay. So you could go like here, you could do a zoom of this part, okay, and then you see details on this one, might be this one, okay. So you see here that in this case and in this case, the AMR is going at no speed. Okay, you could go back like here and say recently used this one and come back and see what you had before. But the good thing of that is that you could filter for many things. Like I don't know, this for me that is the great thing. Say, hey, I want to see what is happening exactly in this moment because it's very confusing or whatever, or why are there so many warning fields? 60%, is this normal or not? And this could help you to improve the performance of the AMR or the installation. I don't know, you might change the routes or whatever. But this is just an example. You could have a dashboard with whatever you want to measure the performance of your AMR, to measure the time it takes to go from here to there, or whatever things. Okay, so basically this is the idea of what I wanted to show you. So thank you very much, and I hope this has been interesting for you somehow. Just click on below if you like this video and put any comment, and I'll try to answer if I could. Okay, so thank you and enjoy the day. Bye.